I'm going to look at a couple of things in this video related to rotations and travel around the sun. You probably discovered something in the stellarium activity that the star Mintaka was rising about 4 minutes earlier every day. We're going to figure out why that happens to be the case. Let's imagine the Earth here with an observer standing on it, and suppose their eastern horizon is pointing at something that they want to see in the night sky. Maybe it's some kind of a star that they're studying or just like to look at. If you extend their eastern horizon out into space, it's going to be sweeping past that star in just a minute or two. So the star will be rising on their eastern horizon. Now, if we go through one rotation of the Earth, keeping the Earth centered on us here, so again, the star is on the observer's eastern horizon. How long will that take? That single rotation takes about 23 hours, 56 minutes, and 4 seconds. Now, in the stellarium activity, you couldn't measure the time that precisely. You didn't have seconds on there, for instance, but this is about what it is. There's actually a bit more to it than that. There's, let's see, 0.0105 seconds tagged onto the 4 seconds, but 23 hours, 56 minutes, and 4 seconds is okay. 23 hours, 56 minutes is close enough for most purposes. So, how can that be? Let's see. It'll involve a little bit of animation, but we can figure this out. Now, I have just the Earth drawn here. It's just a blue dot, but I have an eastern and a western horizon on it. We'll imagine that at this time, the eastern horizon is pointing at the sun, so the sun would be way off there to the left. We don't care what the western horizon is pointing at. So we'll have this go through one complete rotation. But it's doing something else. It's not just rotating, it's moving through space at the same time. And that's the key idea that causes that 4-minute change. We'll extend that eastern horizon out there, but it turns out it's not pointing to the sun anymore, or not yet, at least. This is one of those rotations with respect to the stars. Okay, the Earth has moved. The path it took to get from the initial point up to there is its orbit around the sun. From their position here, or the position of the observer whose horizon we're talking about, a line to the sun, or a line from the sun, points down at an angle there. And so the Earth would have to turn a little bit farther. Remember, the green arrow will sweep downward as the Earth turns on its axis, so it'll have to turn a little bit farther before the sun is on the eastern horizon. And that's what's going on. It'll have to turn for about 3 minutes and 56 seconds longer before the horizon again points at the sun. So we can put some names to things now. First, the sidereal day, or sidereal day. It's approximately one rotation of the Earth with respect to the fixed stars. Now, it's not exactly that because the Earth precesses with that 26,000-year cycle, so that screws things up a tiny bit, but not much. Anyway, that rotation of the Earth with respect to the fixed stars, approximately, is a sidereal day, also called a sidereal day, and it's 23 hours, 56 minutes, and 4 seconds, approximately. The synodic day, for Earth, it's the average period for one rotation with respect to the sun. That's what our 24-hour clock is based on. We've got a little bit of a difference between the two, the 3 minutes and 56 seconds. The sidereal day is shorter than the synodic day by that amount. So that explains why those stars were rising about 4 minutes earlier every day, those that you looked at. Revolutions of the moon. How long is a moonth? The word month had its origins relating to the moon. It was a moon cycle is what it started off as, and it's gotten tweaked quite a bit over the years. But how long is that? So let's figure that out. This drawing is not to scale. I've got something off on the left end there. The yellow ball represents the sun, the blue ball represents the earth, and the white ball represents the moon. This orientation of the sun, earth, and moon, when they're in a line like that, and the moon's on the far side of the earth from the sun, is when a full moon would occur. And I just picked Gemini as where the moon is appearing from Earth's viewpoint at this full moon. Gemini is one of the constellations that the moon will travel through, and at some time during the year the full moon will be in Gemini. Here's a ray of light from the sun, goes past the earth, hits the moon. Some of it going in the same direction will continue on, pointing in the direction to Gemini. So now let's have a rotation of the moon around the earth. What's with this extra motion? Well, the earth is orbiting the sun, and in that month, while the moon was orbiting the earth was orbiting the sun, and the orientation has changed. The moon is again in Gemini 27.3 days later, but it's only a waxing gibbous moon with the orientation that we have here. Remember, the moon is traveling in a counterclockwise direction around the earth, and it has a bit farther to go before it will be full. Earth has to go a bit farther, and it'll be 2.2 days after the moon was in the same constellation of Gemini, but it's not going to be in Gemini for this full moon. It'll be either in Cancer or Leo, which are constellations to the east of Gemini in the sky. But again, we have a full moon now, but it was more than a full rotation there. So we've got a couple of different definitions for the month now. The sidereal month, or sidereal month, is the time it takes the moon to return to a similar position among the stars. It's about 27.3 days long. The moon won't return to an identical position among the stars because it'll probably be a little ways north or south of its position that it was 27.3 days again, higher or lower in the sky a little bit, because that changes throughout the year. The synodic month, which is also called a lunation, that's the average period of the moon's orbit with respect to a line joining the earth and sun. So it's about 29.5 days, but it would be new moon to new moon, or full moon to full moon, or something like that. And that's the synodic month or the lunation. So now we've got two different types of months, the sidereal month and the synodic month or the synodic month. And we also have the sidereal day and the synodic day. So make sure you can keep those straight. And now you know why those stars rose 4 minutes earlier every day.